when it comes down to it, for something like this, and I'll just give you a little bit of a preamble, is they're saying that these two triangles are similar. How do I know? I know what that little strip of bacon means, right? That means something to me. So for the rest of these guys, what is it that I'm actually being asked to do? Well, a correct version of this could be something like, let's just say, C to D. So that would be the height of the triangle. So C to D would be over, well, I guess I would probably put it the other way around. Let's just say D to C, and then we'll say C to B. Okay? That would essentially be a proportional pair, right? Those are both the same side length. And so then we could also do something like, oh, I don't know, C to A, which is the base of the bigger triangle, would be combined with B to A. So C to A would be combined with B to A. That would be a correct one. I want you to run through these guys and see, are there any of these pairings that are done correctly? So give that a shot. Through this guy. So when I go to try and pair the proportions, this one is sneaky, the closest to being what would make sense, right? Let's actually sketch it out on here. So I'll erase this guy that's here. Again, this is an example of what like a correct version would look like, just to kind of give you an example. But AB over AC, so this is small over big, and let's just see the sides. So AB over AC, that makes sense. That's the bottom of the small, that's the bottom of the big guy. So that checks out as a proportion. But then all of a sudden I've got AD over AC. Now, does AD over AC actually make sense? Yeah, that is a pairing. Like those two go together, but this guy is big over small. So because it's jumbled, it doesn't work. Again, abstract, challenging, just trying to be annoying. So that one's out. If we go down and look at C right there, AD, so AD is this guy, over DC. It can't be on the same triangle. That makes no sense. Big over big doesn't make any sense at all. So I don't even need to do anything else. Like automatically that guy's ruined. Okay? And then BC over CD. So if I have my BC over CD, hey, that guy works. Small over big. But then I go DA. So all of a sudden I'm dealing with the bigger triangle again. Big triangles on top. Really, no matter what happens now, that doesn't work. It's jumbled. I would need to have part of the small triangle on top for that to work. Okay? And then last but not least, we've got a BC over AB. And again, we're talking about a small over a small, so I can reject that one. Yes, I was a jerk. This is none of the above. I was just trying to get you to think differently, and that's basically it. Okay? But so it's the way.
It's like, yeah, I didn't realize I would have.
Perfect.
C because like it would have been the one that I wouldn't have.
Right. Okay. But I mean, it's mainly just trying to get you to think of the proportions have to be, if I put big over small, then it would have to be big over small.
Yeah.
Or vice versa. This guy started small over big. So the other side, if this guy was AB over AC and AC over AD, then that one works out. Only because it's going to be small over big, right? And you could also flip it. There's no difference between that and saying AC over AB is equal to AD over AC. As long as it's paired like proportionally and correctly, then it will work. So it's just trying to get you to, I'd say think outside the box, but think outside the triangle.
No, I was thinking outside half the
Think
box.
outside the triangle.
Outside half the box.
These guys here, I'll have you try them on your own. Before you get started.
Very bad.
Now, let's put that line right there.
Won't be useful.
Won't
I
be
need to call
useful.
Leia.
Choose. Or I could just
It
say,
even says in the question.
I know it says in the question. I was just going to put obtuse / JC, but I thought that would be too obvious. And we're recording. So I'll just go over this guy quick. I think most of you guys are pretty good at it, but when I pair this guy off or set it up, 40 and 22 and 30 and that angle there is what we're looking for. Only problem is it's not going to give us the obtuse. It's actually just going to give us the acute version of it. We'll have to do 180 minus our answer.
I got
So let's just double check it. So if I go A over sine A, B over sine B, we're going to go 22 over sine 40, right? And then you're going to have 30 over sine B. So in my calculator, the hope would be that I'm going to have it set up to say 30 times sine 40, set brackets around that, and then go divide by 22, right? And I should end up with something like 61.2. Did you get 61.2?
I don't know.
I think
Okay.
I said-
So, roughly speaking, that's what you should get when things pair off. Then knowing that it's obtuse, I would go 180 minus 61.2 and end up with 118.8.
It's because Lay's simple.
I would say so. Yeah. Now I can just the only thing I would check is when you paired things off, was the 30 over the guy you're looking for, was the 22 over the sine 40,
Yeah.
right?
I think I put in my calculator.
And then yeah, just look at that string of values and go, did I do that guy right there? But don't forget that we're having to subtract by 180, and then hence why we would land with 118.8. Now, the next guy is challenging. I don't know how many people, has anyone actually gotten through to it yet?
Yes.
Okay, JC, have you looked at it yet?
No.
Okay, so let's just talk about it together because this guy can be a bit more challenging. And I like both of these questions right here because very highly likely that, 100% at least one of these guys will be on your end of year exam. Very high likelihood that both of these guys are on your end of year exam. Okay? I really like these ones here. What is the key word when I read through it? Consider all the triangles below. I'm considering. Which of the following triangles is, don't worry about necessarily. I don't really think that word is necessarily necessary.
It's not.
The word we're key on using there is similar. What? I'm leaning into the dad jokes. I feel like I gotta. Anyway. So, similar is the key word. There's my little strip of bacon. What does that mean? That means that there are three theories I'm going to look to try and prove this guy with. Okay? So, side, 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 and angle, angle. If I look down, there's none of these that'll work for angle, angle, so that guy's out. I'm going to put labels on each one of these in terms of how I will approach it. That guy I'll have to solve using side, side, side. That guy I'll have to try and solve using side, angle, side. Same thing down here. Side, side, side. Side, angle, side. Any questions on that in terms of why I've labeled those the way that I did? Okay. So when you run through it, basically all I'm going to end up doing is putting what's the biggest side on A, so 11, biggest side on the one we're looking to prove, 10. And then 9 over 8. And then 6 over 5. Now, if I know my fractions and I know my mathing, 11 divided by 10 and 9 divided by 8 aren't going to match up. Just because they're one away from each other doesn't mean the proportions aren't going to work out, right? 11 tenths is different than 9 eighths. You can try it out if you want, but I can tell you right now that this is going to be like, obviously 1.1. And then, what's it? And then 9 divided by 8 is, like you said, 1.125. So super close, but they have to be exactly the same and they're not, so we reject it. So this guy gets rejected. The next one that becomes a bit more challenging is, let's look at where this angle is here. So for that angle, let's take a look up here. It is touching two side lengths. It has a smaller and it has a bigger. This guy has a smaller and it has a bigger value attached to that angle. I'm not concerned with the 10 in this case right now because it's not in that horseshoe I care about. It needs to be in side, angle, side order. Side, angle, side order. And I'm choosing the smallest to pair with the smallest and the biggest to pair with the biggest. So I would have basically 32 over 8 and 20 over 5. Well, I know those are both going to be equal to 4. So I can stop right there. C is going to be the answer on that guy. Right? But that's all you're doing. You're working through proportions. Yep.
I didn't realize I had to do like the SSS and SAS. I just kind of looked at them and so like 20 was kind of like a 4-ish of 5.
Yeah.
And 32 of 8. And other ones didn't necessarily match up.
So it's to say you're using the same logic, so that's good. Like that's fine. The more specific thing to pay attention to will be when it says congruent, right? For congruent, they'll have to be exactly the same. So that's the only thing for the word choice there is when they say similar versus saying congruent, you're going to be looking for different things. And those are the two phrases that they'll use, right? Congruent means identical. Similar means proportional, right? So then I guess I've already kind of ripped through this guy here, so I'll delete that guy.
The next one,
But,
the stupid one, how they made
it's not. Well, okay, it's kind of. Oh, yes, it is. I see what you mean. Yes, the way he's a 90, but then that one's not, so it makes you think. Yes, it is. Yeah, but okay. I'll erase it. I'll pause it. So hold on. Let me just get set up. So you've gone through this and found out with let's just say SOHCAHTOA that there's my hypotenuse. There's the opposite. I'm going to get in this case here 5.09. Right? Most people have been able to get to there using SOHCAHTOA, sine law, whatever, because the 90 pairs of this guy. Fine. If you know this 3 and that 51.3 and that 5.09, and it's not like triangle ABD, where when you saw he was 5.09, this guy has to be 5.09 because that's the same angle as that, so that side length would have to be the same as that. So this one was easy. We're just going to use base times height divided by 2. 5.09 times 5.09 divided by 2 is equal to 12.8 or something like that. When you go to this one here, the base times height's not really going to work on that one.
Can I use the AB sign?
Yeah, so I would lean towards this guy here, but when I start to look at it, and this is the only guidance I'll say, we can either find that length because I already have this angle in that one. That's a version of this guy. Okay, or what I can do is I have this one and this length. So what if I find that angle right there? Then I could use the AB sine C. Because I already have the two side lengths. The only problem is finding that angle's just a little tricky. It's not too crazy, but it is a little tricky.
And how come I can't use 3 and 5.09?
For like base times height?
No, just for this one. Like, why can't I have 2?
Oh, okay, perfect. So the AB sine C, the title I give him is, right, he's the side angle side version. It's got to be in that horseshoe, right? It's got to be wrapped around. Otherwise, it's because this way, 3, 51, and 5.09, we're missing that whole side length and that angle. I need to have a part of either the one of the angles or one of the side lengths paired with it. So I'll let you try and think about it. It's a bit of a challenging leap, but you can get there. But I'll validate it here once I go through this. So for those that didn't finish this guy yet, I'll walk you through how I would basically do this guy. It's not necessarily saying it's the right way.
I got
It's just
7.2.
I think that's pretty well bang on. Like if I wanted to find that, I know I have that length and that length, so I want to find that obtuse angle. How would you get that angle right now, knowing that the 3 pairs of this guy and the 5.09 pairs of this guy? So I can't actually find this one, but
I found the top
I can find the top one. So what if I did that and did sine law and did 5.09 over sine 51.0 or 51.3, and then 3 over sine B, what did you get?
46. It was like 45.99.
Let me just try it. So 3 times sine 51.3. No, 3 sine 51.3 equals divided by 5.09. 0.459. Oh, 0.459, but inverse of that would be 27.3.
Oh, I never did the inverse.
Do the inverse to get it. The decimal is just the ratio; it's not the actual angle. But so now that's going to throw things off. We're going to end up with, right, to get the angle B, 180 minus 27.3 minus 51.3, and 180 minus 51.3 minus 27.3 is 101.4. So now that I actually have that guy to work with, so 101.4, I've got the 3, I've still got 5.09. I can then plug all of those things into this formula because it's in the right order, the side angle side. So 5.09 times 3 times sine 101.4 all divided by 2. And that's going to give me something specific. Sine. So it's still 7 something. Oh. 3 times. So then 7.5, yeah. So once I have the 7.5 right there, I'm basically done. Now again, there's other ways to do it. You could have found this guy here. You would have had the 51.3 and the 3. But that was probably your fastest method. Not to say it's right, but it would have been the fastest. The sketching of this guy here. So I'll feel free to try and sketch it on your own. Just know that this guy here is obtuse. Okay. When trying to figure this guy out, I know I've really got to just find angle B and
Please excuse this interruption.
basically we can solve for B right away, but we know it's obtuse. They've added that in there. We're going to just use sine law to pair these guys off. So let's see if your sketching actually works. I'm fascinated to see if that actually will come to fruition. But 5.8 over sine 35 is equal to 8.7 over sine B. So taking the inverse of all this stuff, 8.7 times sine 35.
It's 120.642449.
Okay.
20.64, yeah.
She wrote Swedes as SW.
Hold on, we're recording. We'll just talk about this in a second here. Boom. And then all of that. Oh, internally. Wait, did I put the brackets in right? Bracket divided by sine 35. No, divided by 5.8. And end up with something like, did you get 59.36? So 180 minus 59.36 gives me something like 120.64. So that angle would be 120.64, which means 180 minus 120.64 minus the 35 is going to give me the remaining angle of 24.36 in that corner. So that's going to give me the angle C, not that it was asking for it, but oh yeah, it's saying solve all the information. So we want to find those guys there. And then last but not least, we could figure out what that piece is there now using sine law again. But this sketch it out, what'd you get?
4.17 for the last night.
And that makes sense because it should be smaller than the 5.8 because it's with 24. So you got 4 point what? 1.7. I trust that. That's good. So that's all that guy is there, is just basically a sine law one, but don't forget, once I get this angle, we would have to add in the 180 minus that to get the 120.64. And then we're basically set. So from there, this guy has a nice little challenge. There's like 3 or 4 ways to get it, but go ahead and try that one. See where you're at.
What we just did?
So the one that we just did, I'll just kind of show my approach to it would be looking at this knowing I want to solve that guy right there as a length, the C to D. We can get this angle, which will essentially give us this angle here. In fact, we know that if I run together 6.4 over sine 32 and 9.4 over sine B, this is actually going to give me the acute angle no matter what. If the answer it gives me, 51.1, is actually going to be that guy right there. Now I can just use SOHCAHTOA and realize that I'm looking for the adjacent. I have the hypotenuse, so I can choose cosine and go cosine 51.1 is equal to an x value over a 6.4. So I'll be multiplying them, and I basically get a value of x is equal to 4. That is like your shortest route. Doesn't mean it's the right route, but that would be your shortest path to the answer.
I don't know. I was solving 2 different ways for no reason.
Okay.